Welcome to part 4 of the advanced video tutorial for the Egcobox software. We shall take our dimensioning of the corner balcony from part 3 of the video as the basis. In the previous video, we added a rainfall downpipe and changed the connection length of the Egcobox. Now we shall modify the corner balcony further and introduce columns and upstands to avoid a warning about deflection. For now, we consider the dead weight at 5.3 kN per square meter and the total weight of 127.8 kN. We'll begin with one column. For this, we switch to the Connection Supports tab. Besides adding the Egcobox here, there is also the option to add a point support or a line support. For a column, we use the command Add Point Support and place the support about 20 cm from node 7. Now a point bearing appears in the detail view. We do not need an element for transmitting moment and transverse forces for the column that is currently there. To adapt this, we select Connection 3 in the detail view. Here in the lowest drop-down field, there is the selection of the Egcobox support. In the drop-down field, 3 connection types are available. In addition to the connection for moment and shear force, there are also selection options transverse force and shear force without pressure introduction. Shear force without pressure introduction is applicable only for opposing Egcobox connections, e.g. for loggia balconies, to avoid stress from thermal expansion. But the system only works if an Egcobox for transmitting shear forces is present on the opposite side of the loggia. An Egcobox for shear force can also introduce the horizontal forces arising in the connection via a pressure element. The horizontal forces present in the connection of the Egcobox, shear forces without pressure introduction, must therefore be diverted via a client-provided tie member to the opposite Egcobox element for transmission with shear forces. For further explanation of the connection of loggia balconies, please refer to the Egcobox technical brochure. In this case, we only have a column support and no Egcobox opposite. Therefore, our choice for the Egcobox is shear force. Thus, we have defined the Egcobox in Connection 3 as Egcobox for transmitting only transverse force elements. Let us assume the architect has decided to choose a large parapet instead of light railing. For this, we could modify the weight of the railing in the detail view in the Loads tab. As an illustration, we select Railing number 1. Here we can input permanent and variable loads in the horizontal as well as the vertical direction. However, in our example, we want to use the parapet as stiffening in order to somewhat reduce the large deformation. For this, we switch to the Geometry tab. Here, in addition to the already known commands Add Node and Recesses, Upstands can be selected. 3 options are available: the rectangular upstand, the round upstand, and the edge upstand. As we wish to design a large parapet, the command Edge Upstand lends itself. After selecting this command, we can click on all edges on which the parapet is to lie. Our newly placed upstand immediately appears in the detailed description. In this context, we should mention that no edge upstand can be set on the sides where Egcobox is planned. In these areas, we would have to select a rectangular upstand. However, in our example, we do not require an upstand where the Egcobox is located. The newly input upstand has a default thickness and height of 5 cm. We shall increase this to 15 cm thickness and 90 cm height. We can see again how the shape of the parapet changes in the floor plan. We would normally reduce the vertical loads from the handrails, but for our example, we won't carry out this step. We must leave the horizontal load as a collision load, as this is not considered when inputting the upstand. Now let's check our dimensioning and carry out a calculation. As an advanced user of our software, you will already know these operations. we note that the warning about deflection raised at the beginning of the video has disappeared. Finally, let's check in the tab Loads whether the dead weight has changed. Reminder: before introducing the edge upstand, the dead weight was 5.3 kN per square meter and the total weight 127.8 kN. Now the weights have increased to 7.4 kN per square meter and 179 kN. But here too, as with the specification of recesses, the characteristic dead weight is not applied averaged over all areas, but serves only as an illustration. In general, the loads are taken into account where they are applied in the input. For a better visualization, we use the cube to change to perspective and go back to the results overview in the Calculation tab. There remains the outlook to the next video. In the video part 5, we shall take another closer look at the output options. We hope you will join us once again.